Good evening, guys. So for this video I will be showing you how to use this sensor. This is a 120-degree flame sensor from Newway. So for this experiment I will be using the following. So I need to start a fire, an Arduino, the flame sensor, some wires, and a USB cable. For the program I will be using the button example and the analog out serial example. You can find this by default on your IDE already, so you can find this here, the digital library and the analog library. Next, let's take a look at the sensor. So we have here 5 phototransistors. Those are the components that detect the flame, the light. We also have the potentiometer there. So the blue component with the screw on top. So that is the one you use to adjust the digital output sensitivity. So we have here 3 ICs. Those are LM393s, dual comparators. So those components are also part of the digital pins. So if we look at the headers, they are labeled as ground, VCC, D5, A5, so on and so forth. So the ground is connected to the Arduino ground. So the VCC is connected to 5 volts. The pins labeled as D, those are the digital pins. And the ones labeled as A, those are the analog pins. So as we can see here, the digital pins are located at the bottom row, while the analog pins are on the top row. So if we turn this to the side, so we can see here the rows. So the top row are analog pins, and the bottom row are digital pins. Okay, so next we have to connect the flame sensor to the Arduino. So if we are to follow the button example, we have to connect the digital output from the flame sensor to pin 2 of the Arduino, and the analog output from the flame sensor to the A0 of Arduino. That one is for the analog in serial out example. So if we look at here closer, the ground and the VCC, yellow and green wires, are connected to the Arduino ground. The green wire is connected to 5 volts, while the yellow wire is connected to ground. So the blue wire A0 is connected to A5, while the digital pin D4 is connected to pin 2 of the Arduino. So first we're going to test the digital pins of the flame sensors. For that we'll be using the button example that already comes with Arduino. So if we take a closer look at the program, you can see that let's scroll this to the top. So we can see here that the an LED is assigned to pin 13. So that's already there. There's an onboard LED connected to pin 13. So a push button, the push button is assigned to pin 2. So pin 2 is set as an input. This 10K resistor is no longer needed. So this particular program is made for a button, for a push button. So we're going to use the flame sensor. It's going to act as a push button. So we no longer need pull up or a pull down resistor connected to that. So it already has high and low output, so we don't need pull downs. So here we can see that the LED pin, the pin 13 here, is assigned as an output. So that's just that's correct. So we have here the button pin, which is supposed to be an input. So that is pin 2, assigned to pin 2. So next we go to the loop. So here we can see the program tries to read the state of button pin, which is pin 2, and if it returns high, and it's going to turn the LED on. Otherwise, if it's off or it's low, it's going to turn the LED off here. So to demonstrate that, we have here the setup again. So I have to light the candle, so please wait for me just for a bit. So it's unfortunately the lighter the lighter didn't work, so I'm going to use the match. There. So next here we're going to test the flame sensor. If we look at this closely, okay, so it's yeah, there. I thought it won't focus. So here we can see H1, H2, H3, and H4 and H5. So those are the photo transistors. So we are connected right now to D1. Sorry, I adjusted the connection to D1. But anyway, it's still the same. So D1 is connected to H1. So we can see that H1 there is lit up. So we have here, so the pin 13 is supposed to light up. So there, so it's lighting up. So let's zoom this out. Okay, it won't focus. Okay, there. So it's lit up. So if we move the candle to the left, you can see that the LED light there on the sensor turns off, and so does the light here on the Arduino. So if we move the candle to the right, you can see there it goes up on. So if we there, off, on, off, on, off, on. There. Okay. Okay, so next we have to test the analog output of the flame sensor, and for that we're going to use the analog in out serial program that comes with Arduino IDE. So if we take a closer look at the program, so we can see here that we need a potentiometer connected to analog pin 0, A0, and also one LED connected to pin 9. So basically what this program does is it fades in and fades out the LED connected to pin 9, because pin 9 is a PWM output, and according to the potentiometer, the input voltage on A0. So the potential with using the potentiometer, you can adjust that from 0 to 5 volts. So if you have there 0, then there's no light, the LED won't light. So if you put there 5, that's maximum light. So in between, you can see it fade in and fade out. So here we can see, we scroll down. Oh, by the way, I'm sorry for the camera, I'm just using my cell phone right now. So we can see here A0 is assigned as an analog input pin, and 9 is an analog output pin. Okay, so if we can see here that we're going to use the serial monitor, and there, the first line of the loop we have here analog read. So we're trying to read the value of A0, and then we're going to map that value between 0 to 255. So whatever the value is there, we're going to ratio that between 0 to 255, and then output that to your serial monitor over there. Also, to understand it further, let's just test this. So first, let's load this program to the Arduino. I'm sorry, I haven't uploaded it yet. So board, okay. So let's upload that. So it's uploading right now. There. Okay. So let's turn the serial monitor on. So we have here the serial monitor. So we can see there it's 0, because in our setup here there is no flame. So I'm sorry, so bear with me. I'm just going to light the candle again using my handy match here. There. Okay, this is so Stone Age. So the candle is lit. Happy birthday. There. So if we take a closer look at the sensor here, we can see that, let me focus this a bit. Okay. Oh. No. Just a second, please. There. So we can see here that the A5 is connected to the blue wire there. That's connected to A5. So that wire is connected to your A0 over here. So the reason why RX and TX are lit up, it's because TX is lit up. That's because we are transmitting to the serial monitor here. As you can see. There. So earlier there was 0 there. So there was no value read there. So now we have there a value. So as I put the flame closer to A5, H5 here, we can see that the value rises. The sensor value rises. So if we move this farther, but it should still be lit there, we can see the value is smaller there. So let's try and move this until the LED goes off. There. Okay, so yeah, that's off. So we can see here, even though the LED is off, we can still see a value there. Okay, so that's for testing the analog output. So to summarize, so the digital outputs that can only provide you with high or low, while the analog outputs can give you the actual reading from the phototransistor, no? So what is that? What good is that for? So if we can use the digital output of this to like provide a set point. So if like for example we're using this as an alarm for an alarm system, so we can adjust the sensitivity using this potentiometer, and then we can just give a set point. So when the flame intensity or the distance of the flame increases and it goes over the set point, you are provided with a digital output here, a high output here. And if not, then it remains low. So while on the other hand, if we're going to use the analog output, with the analog output we can actually determine the distance of the flame or the strength of the flame, and so on and so forth. So it really depends on what you're going to use this for. So there. So I hope that helps, and thank you for watching.